Industry Insights, co-creating the future with AI and data. This session highlights the importance of collaboration between research and industry in shaping the future of artificial intelligence. Please join me in warmly welcoming Dr. István Szászi, representative of the Bosch Group in Hungary and the Adriatic region, the head of the Middle and Eastern European Engineering Cluster, and the managing director of Robert Bosch Ltd. We are especially honored to have Bosch as the platinum sponsor of this year's AI Symposium, a fitting partnership as one of the world's leading industrial and technology companies standing at the forefront of research, innovation, and AI-driven industrial transformation, helping shape the future of mobility, manufacturing, and intelligent technologies worldwide. Please welcome István Szászi.
We talk a lot about the AI features on product level, and only a few people is interesting, what happens in product development and in production. And these topics are exactly important to deal with and to understand. And the reason is that if you look at the current challenges in the automotive industry, then we have a huge and enormous time pressure. We have a lot of challenges, and we need a kind of paradigm change. And one help and tool could be the AI, the way we have to use in the product development and also in the production. But anyway, today it's not the focus of my presentation. I just want to show you some reuse cases on product level. I just call them as a features, AI features in the product. The examples I want to show you is coming from the ADAS, Advanced Driver Assistance Systems, and those who are familiar with this topic, you could say that for sure AI on feature level, product level is already available in the car. But the point is that we have task-orientated kind of software architecture, software modules, which tries also to solve some issues. Lane detection, object detection based on radar system, based on video camera system. But the point is that we don't have a unified, scalable AI structure and architecture which could help us to create and generate the real-world challenges and to create more understanding and a better understanding what happens on the car level. If you look at today's automotive AI systems, then certainly and obviously we have certain limitations on that. We call also that the system, the current software architectures, they are generating boxes, based on video camera, based on radar sensor. And what we can see, the car is seeing not as just boxes, which are the objects on the street. This could be vehicles, this could be pedestrian, this could be trucks or any objects. But it's nothing else. There is no connection between the objects. If you want to make a kind of prediction what happens, what could happen in between the different participants of the traffic, then it's pretty much hard to say anything else because you do not know what the different participants intend to do and what are the interactions and what about the real world. So that means basically but before we jump into the current solutions or the future solutions, there are even serious problems which the current system are not able to really handle these challenges. I put on the slide 3 challenges. The first one is the human and the machine connection and the interaction. You can see basically a traffic with the ego vehicle. There is a car which is moving in front of your ego vehicle, and the video-based systems are not able to really understand what happens really in that special traffic situation. If there is a kind of accident on the street and everything is on the street, then this situation is too complicated for the current sensor systems which we have available in the car. And for sure there could be surprising situations, and these are those topics where we need a much deeper understanding what happens on the street. So we could also say that these traditional programming-based solutions, which is nothing else just if-then algorithm, if we describe the scene, then we can conclude what to do, which actions, steering action, accelerating, stop the car, brake the car, which actions we can initiate. So these methods are not able to and not capable to solve those challenges. What we need basically not only to have a kind of AI architecture which has a better understanding about the real world, but we have to have also architecture which is scalable. Because if somebody knows the vehicle architecture, then knows exactly that if we deliver as a supplier, as a kind of company, technological company, those systems and those technological solutions, then it's not one fits to all. So we have to consider the all vehicle segments. We have basically the entry segment where we have to have the must ADAS systems. We have the mid segment where we have cost-effective innovations. And we have for sure the premium, the luxury segment or the high-end segment where we have performance-driven features. So everything what we are doing and creating in terms of architecture, could be software architecture, could be AI architecture, we have to consider this kind of segmentation. The point is what we are doing at Bosch. We clustered and layered the architecture into two parts and two layers. The first one is the system layer one, where we are using for sure the AI perception, the AI fusion, and the AI prediction and planning. But this is basically where the layer should have a very fast reaction. So should be very deterministic and should be able to run software modules in real time. That's very important from safety aspects and also from any aspects point of view. For sure, you can see also that in this layer, we heavily use the AI topic. Also in the perception, I will also show later real use cases and real examples what we are doing. The second one is the system number two, the layer number two, which is basically the AI slower but more precise layer, where we have even deeper and wider understanding what the real world is. Basically, this is what the layer, this provides a lot of important information. We could also foundation model, a lot of information towards the layer number one. And with the collaboration, these two layers, we could use the sensor information from all sources, video camera, radar sensor, LiDAR. And end of the day, we can generate and create the real world. Let's look at what happens in detail. So if we have the camera system, radar, LiDAR, and the map data, then for sure we have to have the perception layer. In the past, we didn't have any AI perception, just we took the sensor data. And for sure, at this layer, at this point, we use also the AI to have a better sensor understanding what the video camera, radar sensor, and LiDAR sensor are seeing on the street. But based on this AI perception, as you can see on the picture, we won't see only boxes on the street, which are the pedestrian, the trucks, the bicycle, motorcycle, and so on. But we will understand much better what happens. We will understand much better that if there is a crosswalk on the street, if we are moving, in a quiet suburb area, if we are next to the construction, if we are somewhere else next to the school or kindergarten, then we could have a much better, I would say, context understanding and semantic reasoning, what could happen, which scenarios could be relevant for my ego vehicle. Because if somebody is crossing the street, then in the previous, I would say, standard traditional methods, we could see only a kind of box or object is moving on the street. But if you understand that that happens in a special area and there are more interactions between the traffic participants, then I could have a much better understanding how can I derive the actions. So that's what we are doing. It's called AI fusion. And based on the AI fusion, we we could and we are able to make a prediction and also make a planning for my ego vehicle. What is the steering angle? What is basically the braking action, or even I have to speed up, I have to accelerate, or I have to stop. So these are basically the actuators what I'm using on vehicle level. Let's look at the system number 2 level. Again, back to the traditional methods. These are the software architecture, the if-then kind of mindset. What we did in the past, if we have seen an object, for example, on the crosswalk, pedestrian is crossing the street, then we said if the distance is, I don't know, 2-3 meters, then the car should stop and certain brake pressure should be applied. But for sure, based on the foundation model and also the vision language action model, it's also possible to incorporate the semantic reasoning and the context understanding information, and it's also possible that based on the VLA, the situation or the car has a much deeper understanding what happens in front of the vehicle. Let's look at one very specific example. This is a crossing street. On the crosswalk, pedestrians are moving. And basically what the VLA, the vision language model, is doing is nothing else, just first of all, the description of the scene. In this case, we see pedestrians are crossing the road in front of the ego vehicle. The traffic light is red. The second one is a short-term prediction. And pedestrian will continue crossing the road and the traffic light will eventually turn green. And the next phase is scenario prediction. So the first point is pedestrian finish crossing and the light turns green, allowing the ego vehicle to proceed. Second point here, more pedestrians may approach the crosswalk, requiring the ego vehicle to remain stopped. And the third one is the traffic light remains red and the ego vehicle continues to wait. And after this kind of prediction, we have the meta action reasoning, which is nothing else, just the ego vehicle is stopped completely to allow pedestrian to cross safely and because the traffic light is red. And the last one is the meta action, which is in case of car that goes into the lateral and the longitudinal direction. In case of lateral maneuver, follow the lane, right? And in case of longitudinal maneuver, stop. So this is basically what the language model, the vision language model, could do based on the foundation model within the car. Let's look at one particular example, which is taking place in a suburb area or even a quiet residential area. And if somebody learned driving, then you know that, if you see a rolling ball on the street, that could indicate, at least in a human being, that a child maybe will cross the road, because that's the way we socialized and that's the way we learned also driving. But if you look back in case of the traditional systems, what the video camera is saying, if the video camera is seeing, this rolling object, as long the rolling object on the street, the video camera could say to the car, stop the car and or decelerate the car. But the traditional system will never say that, okay, maybe a child will cross the street. But based on this vision language model and the foundation model, and looking at the vision encoder and the vision language connector and the language model, the context understanding will that yes, the car is moving, looking at the surrounding of this vehicle, the car is running in a quiet residential area, which indicates that basically there could be a consequence of the rolling ball. And in this case, maybe before any action is taking place, the emergency brake system will be at least pre-filled, not really activated, but at least prepared. If something happens, then I can interact and I can do something. And this is thanks to this kind of AI software architecture. The second example is taking place on a highway, And that shows basically the car with the train is gonna be unstable. And if somebody learned driving, then you know exactly that something could happen if that scenario is taking place in front of your vehicle. Naturally, what you will say in this case, decrease the speed of the vehicle, decelerate the vehicle, and watch carefully what happens in front of your vehicle. If you compare this method with the traditional one, the traditional method will say, okay, there is an object which is moving, and nothing happens, at least at the time being. So based on the VLA and based on the vision encoder and language connector, the alert to the driver could be, don't overtake. This is the first action. Maybe decrease the speed of the vehicle and keep the lane. So I think that gives a much better understanding about the revert, what in the revert could happen, and that gives much more safety for the vehicle. Finally, what this kind of mindset and this kind of transformation allows us in the industry to extend the current knowledge, the traditional knowledge what we had in the past in the automotive industry with the context understanding and semantic reasoning. And you could show also in the examples that that helps a lot in the automotive industry, and that gives much more safety for the vehicle, and for sure handles the unexpected situations. And what I haven't seen or I haven't shown today, the nature of conversation and the way you got used to, you are using your smartphone and you have a conversation, nature conversation with your smartphone with large language models. That gives also us the opportunity to have a conversation between you as a driver and the car. And in the future, we also showed in Las Vegas in January on the Consumer Electronics show, the AI cockpit, what we build in the car. And basically, this is a foundation model, a large language model, including also vision language models. And you can also have you can also have navigation based on natural conversation, which helps you for sure not only to give more safety but also to give more comfort for you as a driver. So I think this is the current status, the current transformation which is taking place on feature level, on product level. But not forget the first two chapters, what I was mentioning, that having AI in the production and also in the manufacturing is exactly the same important as having AI features on the product. So this is what Bosch is covering in the technological portfolio, and we are pretty much convinced that that give us also the confidence that we can cover the most latest and greatest challenges in the automotive industry. Thank you very much for your attention. I have time. I was too fast, but anyway, if somebody has a question, then yeah, I'm open for that. It was obvious, so it's not so mathematical, I'm not professor. I'm an industrial guy, but anyway, if you don't understand, yeah.
Thanks for the insightful thoughts. Very interesting about the latest trends. I have heard a story, an example, and it's about morality, ethics. So I'm curious, what is the current stance? The example was that an autonomous car was cruising with 50 kilometers per hour on an average street. A bus is coming towards the car. I think you know what I mean.
Yeah, this is kind of science fiction, but anyway.
There's a bus stop on the right, 10 people waiting for the bus. In front of the car, the bus is approaching the car. Something happens, we don't know, but it changes the lane, comes toward the car. What the AI system will decide, who to protect, whose life is worth to save. The 10, because it calculates that the collision can be avoided by going to the bus stop, but then killing 10 people. Or staying in the lane, but then the driver and the passengers will die. it's a morality question. I think it's very interesting. I'm just curious if you dealt with it, what's the current stance of it?
I won't give you an exact solution for this question, but the point is, if you have an unsolvable problem, which is for the human being is unsolvable, the way you describe, this is something that you as a human, you can't really give a solution for that, right? Because this is kind of trade-off. So option A or option B, I kill X people, or I'm doing something different. But the point is the AI system is just nothing else. Just we will feed also with data. And if there are such situations, we have to prepare the AI system with those data. And end of the day, if the problem is unsolvable, then it stays also unsolvable for the system. But the point is, you believe that you as a human being, that's the hypothesis usually in the mind of the people, that we believe that we as a human being, we can solve those issues much easier, right? But it's not the case. Just go back one step in the early 90s. Some people were, I would say, very skeptical, that, okay, there are some video cameras in the car, there are some radar sensors, and what happens if those systems are not working? And these people had the hypothesis that they, as a human driver, they can do all the time the best decisions, and even after driving 10,000 kilometers, or even per day 1,000 kilometers, for example, and they're going to be tired, and after 100 kilometers, maybe somebody could drive 500 kilometers, maybe somebody could drive 800 kilometers. I can remember I was commuting between Stuttgart and Budapest, and that took maybe 10, 11, 12 hours. And after maybe 5-6 hours, I was a bit tired, and I was not so concentrating, and, maybe I made some failure. But the video camera, radar sensor, the software architecture, the AI architecture, assuming that I feed it with the right data and I prepare the AI architecture in the proper way, is working always the same manner. I'm not talking about the verification validation processes, because this is pretty much tricky. But the point is that the probability that the AI will fail, not considering those aspects where the AI is not prepared because I don't have data, again, just assuming not those cases. The probability that the AI system is working better in a more efficient way, more safe way than itself the human driver is much higher. That's the point. Again, if you describe a situation which is unsolvable in a way, then AI won't give a better solution as you as a human driver. But the probability that if you are facing you as a human driver to that situation for a certain time point, and maybe you are tired, maybe you are not so fast, you have not so fast reaction, you won't give better solution than that system which has been prepared based on some data set. That's the point. It's an ethical question for sure, but I think at Bosch I can tell you that we have compulsory trainings also for the developers, and we consider those aspects. We call them corner cases, right? Because maybe 80-90% of the cases in the street we can cover, we can describe in an easy way, and we have a solution for that. But there are corner cases, maybe 5%, 10%, maybe 15% of the cases, which are pretty much challenging and not so easy. And I think if you ask me what is the maturity level of level 4, level 5 autonomous driving system, which are facing to those situations, I'm telling you that even 5 years back, 90-95% of the cases we solved already. But the remaining 5%, maybe 10%, depends how we see, which is not solved yet. And for sure, that's the reason why we need a lot of data. We have to, if you go to Las Vegas, and you can try also Amazon Zoox, if you go to, or even in China, I was last week in China, and I also tried autonomous driving and robotaxi. If I go to Zagreb, the Mati Rimac CEO, Bugatti CEO, also rolled out I think it's Vern. I mean, that's the name of the robotaxi. 90% of the cases are working properly. That's the reason why they say, okay, certain area of the city, they will roll out where the number of corner cases, and the probability that we have such a, I would say, not so feasible corner cases is less or even tends to zero. I know that I haven't provided such an answer that you leave this building and you will call a robotaxi in Budapest, probably in a couple of years in Budapest, and you could have a better feeling, you know, what happens in the street. But I think that's progress. That's something which is under progress, under construction in a way. And I'm pretty much looking at the industrial trends and also the way my colleagues at Bosch are working. I'm pretty much optimistic that this trend is coming and coming like a big wave. Thanks.
One more question.
Yeah.
Within the upcoming 3 to 5 years, what rate of adoption do you foresee in autonomous driving? China, Las Vegas, Croatia.
In 5 years.
3 to 5 years. Europe.
Europe. I assume that we're going to have more and more robotaxis. You heard maybe that in Budapest there is also a plan to roll out some robotaxis in collaboration with Mobileye. And these are test cases, use cases, which happens currently also in US, also in China, just collecting and gathering data and understand much better those situations. And not only in 2 or 3 to 5 years, but in 1 or 2 years, you will see more and more cars in Europe, in different cities, different countries, different cities on the street, with the purpose just getting and collecting more and more information. And I think in what you asked, basically from 3 to 5 years, we will have not only the test systems and the test vehicles on the street, but also the kind of serious vehicles, what you can order as a robotaxi. That's my prognosis and focus, also in Budapest here.
It's a follow-up question about the scenario that the gentleman just presented, because yes, as humans, we don't have an answer, but we have accountability. So if I will go into the stop and hit 10 people, I will be accounted for that. So how is the accountability issue solved, aside from the moral?
If I heard acoustically right, the responsibility remains still at the supplier. I mean, in case of Bosch, we are supplying the system, then we're going to have the responsibility for sure. At the end of the day, what is the responsibility of the car, right? If I'm switching on such a systems, me as a driver, then there is a joint responsibility, a mutual responsibility between me as a driver and the system. What does it mean? If I'm using this system under the circumstances which is described in so-called manual, right? Then it's fine. So I can get rid of my responsibility as a driver. But if something happens under the circumstances I used this system, then for sure, and something is a kind of malfunction, then the system has the responsibility. What does it mean? The system supplier or even the technological supplier could be OEM, the car manufacturer, or could be also the tier 1 supplier. They will take over, or they do have the responsibility in this case. Thank you very much. It was not the classical university lecture. We are at the university because there were some questions. So I'm also teaching at the university, and I got used to the situation that the students, you are not students, but the students do not have any questions. And I was happy and appreciate very much that you had very interesting questions. Thank you very much.